previous video, I talked about charges, and if I want to talk about charges in this video, I have to talk about chemical reactions as well, because that's how we can come up with charges. Well, I have an example of sodium chloride, and I will explain to you why we need charges if we have a chemical reaction. So basically, for a chemical reaction to happen, we need electrons to transfer from one element to another element. And when this thing happens and an atom basically loses an electron and the other atom basically gains that electron, that's when charges happen, and that's when basically charges are going to change. Because just as I told you in my previous video, when we have a neutral atom or an atom that's basically in nature with nothing else, the number of protons and the number of electrons are equal to each other. However, when we have a chemical reaction, the number of electrons will change, and it's because of the fact that the whole atom is basically surrounded by these electrons, and they are the thing that basically will do all these chemical reaction and all these reactions with other elements. So for example, when we have sodium chloride or Na, which is sodium, and chlorine or Cl, when we have something like this, because these two atoms are going to react with each other, the only things that are going to change is the number of electrons. And it happens because of this it's a rule called the octet rule, and I'm gonna make a video about it later. But all you need to know is for this example is that the charge of sodium will become positive one and the charge of chlorine will become negative one. Well, why they become this, why do they get these charges, this is a video for the next following days, but for later days. But I just want to tell you that whenever we have charges, how do we basically count the number of electrons, protons, and neutrons? Well, it turns out because there's no transfer of protons and neutrons, the number of protons and neutrons should not change and they should stay the same. And the only thing that's changing is the number of electrons, which means if I'm looking at Na plus 1, the number of protons should be the same thing that we see in our periodic table. So in the periodic table, this atomic number of sodium is 11. So my protons, it's equal to 11, and we put a plus charge because we want to indicate that it's a positively charged particle. Now, how do we find the number of neutrons? Neutrons, because their charge is 0, we're going to put a 0 in there. And we know that the atomic mass of sodium is 23. So it's basically 23 minus 11, which will give me 20, which will give me 12, not 21. Okay, 12. Okay, now how do we find the number of electrons? The number of electrons, because we said that the only thing that changes when a reaction happens is the number of electrons, we have to kind of be careful with them. So there's a really good shortcut for this, and I'm just going to give you the shortcut because if I over explain something, I'm sure you will get confused. So I'm just going to give you the shortcut, which is basically the number of protons minus the number of the charge. So the number of protons we have is 11 minus the number of charge, which is plus 1. And if we do 11 minus 1, we get 10, which means the number of electrons should be 10. And it makes sense. Why? Because it's positive. And if you look at our numbers of protons and electrons, you can see that we have more protons than electrons. And when we have more of something, the overall charge should be that thing. And as you can see, the number of protons, which is a positively charged particle, it's 11, and the number of electrons is 10. That's why the overall charge of my sodium is plus 1. Now let's do the same thing with chlorine. Okay, we have chlorine with a minus 1 charge. Now, the first thing I do is the easiest thing, which is protons and neutrons, because they're not going to change. So my proton for chlorine is 17 because the atomic number of chlorine is 17. Now, the number of neutrons is equal to my atomic mass of chlorine, which is 35, minus the number of protons, which is 17. And yes, 35 minus 17, or I believe this is 34. Yeah, okay. 34 minus 17, which is just going to give me 17. Now, the number of electrons, again, kind of tricky, but we have a shortcut, which is basically the number of protons we have, which is 17, minus the number of number of charge, which is minus 1. Now, 17 minus and minus is going to give us positive plus 1, which is 18. Okay. Now, as you can see, the number of electrons is more than the number of protons, which means the overall charge of our element should be negative. And as you can see, the overall charge of our chlorine is minus 1, which means our answer is correct. We have more electrons than protons. That's why the overall charge is minus. And it's negative 1 or minus 1 for chlorine. And for every other element that's charged, this is the method. And I'm pretty sure you're not going to be asked to find the nitrogens for that. And the only thing you need to do is to find the number of electrons. And again, it's really easy. It's just the number of protons minus the charge. And don't forget about the sign of your charge, because that's gonna tell you everything about the element. And in this case, we have 18, which is basically the correct answer. Yep. Thank you.